Hi, welcome to my favorite calculator, Desmos. I'm going to show you some stuff about linear equations. And linear equations start with y equals, usually. And I'll call this, how about 2x? Boom. I have this graph here. It's linear. It's a straight line. So this straight line here, and it's actually proportional because it goes to the origin right there. And this line represents all the solutions to this equation. Now think about what is a solution to an equation. First off, it's an equation because it has an equal sign. And then a solution to this would make the equation a true statement, such as if I have, okay, I'm locked to the number 2. But if I have the 2 times, now I have to choose a number for x. Let's say 3. 3. That is equal to 6. So a solution would be given as an ordered pair, where the first number is the x number and the second number is the y number. The first number in this case was 3. The x number was 3. And the y number ended up being 6. This is a solution right here. It is 3 for x, 6 for y, and we can find 3, 6 on our graph. 3, 1, 2, 3, and 6. 1, 2, 3, 4, 5, 6. Hey, there's a solution right there. I'm going to place a dot right there on 1, 2, 1, 2, 3, 1, 2, 3, 5, 6. There's a solution. I can go anywhere on this line. Let's say, I know. I'll choose -2 for x. So if it's 2, once again it's 2, but now the x number is changed to -2. For x, 2 times -2 is -4. And so for y, I got -4. And I can place a dot. Where is -2? -2, -4, -2, 1, 2, 3, 4, right there on the line again. See? See, these are, so really, whoops, what just happened to my other dot? This dot right here, you need to move. Oh, the whole thing moved. Whoopsie. I don't know how that happened. So I will just make this a little bit smaller. No, I can't. Oh. All right, so I had to erase a few things there, but basically this dot right there, what, I see another dot there. I see another dot there. Oh, look at that. These are all ordered pairs on the, let's see, as solutions. So this would be what? This is 1, 2. And this is 2, 4. And this is 3, 6. Look at that. We can go up and down, all the way down. And we're going to see these, the line cross these grids. Now, these are the nice points. And these are all solutions here. And what we could also see here is we have y equals 2x. And I could say this is plus 0. And you might be thinking, okay, why would you add 0? Well, this follows the slope-intercept form. Y equals mx plus b, where m is known as the slope and b is known as the y-intercept. So this is important because we can see that the y-intercept is 0. And so this y-intercept, so it's 0. This is where our line crosses the y-axis, and see it crosses the y-axis at 0. And the slope here is m, which is 2. And if the slope, which is known as m, I have no idea why, is 2, then that's equal to 2 over 1. And this is also known as the, this is the rise over the run. And so that means from one point to the next, you go up 2 and over 1. Notice here, I'm going from this point, I'm going up 2, 1, 2, and over 1, up 2 and over 1, up 2 and over 1. That's called a constant rate of change. The constant rate of change makes this line go straight. Up 2 and over 1. See, if it wasn't if it was not a constant rate of change, then it might go up 2 and over 1, and then it might go up 3 and over 1, and up 4 and over 1, and so on, or up 1 and over 1, and it just go up this crazy path where it would look something like, this, something like that. That's a terrible line in any case, but that would not be a constant rate of change. So that is how we can use our slope and y-intercept. Now, I'm going to erase all this. I'm going to, yeah, I have the biggest one, and maybe I am, maybe I'm not. Let's see. Yes, okay. So I'm going to erase all this, and hopefully all of it. I can't get this one little piece right here. Why can't I get you? Oh, well. Fine. Now, if I were to, let's see, I want this. So I want this to be maybe +1. Ooh, look at that. Same slope. It goes up 2 and over 1. Check this out. So what changed? Well, the only thing that changed was this +1, and that move, see, it's now not on the origin right there. It goes up 1. So now that's our new y-intercept is 0, 1. So 0, 1. And that's why this is called the y-intercept, because it tells you where on the y-axis is this thing going to cross. It crosses at 0, 1. But we can also see that the slope is still 2. So that means from here now, it's going to go up 2 and over 1. Up 2 and over 1 in every case. So that is very handy. Now, question is, what would happen if I had negative 2x plus 1? Let's think about that. So negative 2x plus 1, I'll put a little negative right there. Boom. Just makes it go down because it's a negative slope. Negative slopes, so that m right there is now negative, and it goes down from left to right. So negative slope goes down, positive slope went up. And we can also see that this goes, down 2 and over 1. So I can take this point and go down to 1, 2 and over 1. Down 2 and over 1. It just keeps doing the same thing. Or from here it goes up 2 and back 1, up 2 and back 1. Same line right there. And all this line represents are the solutions to this equation. For instance, we can take this point right here. What is that point? Did I say this point right here? This point. So this is what? Negative 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So this is negative 3, 7. So I'm betting that if I take this, x is negative 3, so negative 2 times negative 3 plus 1. Negative 2 times negative 3, that is 6 plus 1, and 6 plus 1 is 7, and that is our target because y is 7. That gives us a true statement. That means it's a solution to the equation. Oh boy, that's just wonderful. So, in review, we've learned about the slope-intercept form. We've learned about the solutions to the equations, which are everything on this line, every ordered pair that is on this line. For instance, let me see if I can get this here. There, look at that. As I move this along, this gives me all ordered pairs. So if I stop, oh my God, it's so hard to stop here. It's hard to stop and just not move. So if I did negative 2.05 and 5.1, well, let's see if I can find the points that I did. So this one, I'm getting to the grid here. Oh, there, negative 1 and 3. Negative 1 and 3. Oh my God. It's really hard. Negative 1 and 3. Negative 1 and 3. I stopped right there, and I could show you that negative 1 and 3 is a solution. So if I did negative 1, I should get 3. So this is what? Negative 2 times negative 1 is 2 plus 1 That is 3. So -1 and y equals 3. I could do it that way. So -1 for x and 3 for y. See, that would be -1, 3. That was that point. Now, I could, let me see if I could do this again. Ooh, come on now. I'm so learning with this. Um, anyway, you saw those points. So as I click, all these are ordered pairs. When I put these ordered pairs all up and down here, when I put them into my equation on the left, I will get a true statement. So I do that, all these here. So actually the line is really a whole bunch of millions of dots, and each dot is an ordered pair that works in the solution for the equation. So there you go. I hope you've learned some stuff about linear equations and their graphs and what they mean. Thanks for watching.